Okay, so this is, I kind of call it the endocrine activity, but what we're going to do is we're going to talk about the five big hormones that control your body systemically. So it's insulin and glucagon, cortisol, and thyroid hormone and growth hormone. Now, in order to talk about these, I want to make sure I'm recording. Hold on a minute. Yep, I'm recording. Okay, so there's some basic vocabulary that we need to go over. So glucose, right? That's what we use for energy. And glucose can be stored as glycogen. Okay, now, when glucose is converted to glycogen, that's called glycogenesis. Okay, so think about Genesis. Genesis is like formation or beginning. So when we take glucose and we change it to glycogen, okay, we're storing it. So that's glycogenesis. Okay, now glycogen can be stored in your liver, okay, and in your muscles. Okay, now this reaction can go the other way. Okay, so we can, let's say we eat something, okay, so we eat something, we have a whole bunch of sugar on board, and that sugar needs to be put somewhere, okay, so we can put it into glycogen, okay, and we can hang on to it. Now we can go the other way if we need energy, if we need glucose, okay, so we can go from glycogen to glucose. Okay, and that process is called glycolysis. Okay, and then the lysis, look, lysis. Okay, so lysis is always breaking something apart. Okay, now, Atkins diet people, right? There's also the process where we go from fatty acids, amino acids, to glucose. Okay, so we're not taking a carbohydrate, we're taking something else that's not a carbohydrate and we're turning it into glucose. So when you do these low carb diets, that's what happens. Okay, and this is called gluconeo. Okay, so new genesis. Okay, so that's glucose. Okay, now we want to talk about fats. Okay, so if we take glycerol and fatty acids and we put them together and we make triglycerides, okay, that's called lipogenesis. Okay, so we're making lipids. Now we can go the other way, right? So if we go back this way and we take triglycerides and when we break them down, that's called it's actually lipolysis, but we'll say lipolysis, right? So you can get the idea that when you're lysing, you're breaking something down. Okay, now the next one that we want to talk about, okay, is we want to talk about proteins. Okay, so these are more straightforward in their naming. So if you take amino acids, right, and you turn them into proteins, okay, we call that protein anabolism. So anabolism is the idea that we're building something up. Okay, so anabolic steroids, they're building. Okay, and then if we go the other way, so if we go from proteins to amino acids, guess what we call that? We call that protein catabolism. Okay, so those are the three major macromolecules that we're going to worry about, right? That we're concerned with in our body. I can't spell macromolecules and talk and write at the same time. Okay, so we're either synthesizing or we're breaking down. Okay, now we want to go over the homeostatic systems for each of those hormones that I have so you guys kind of understand what they're doing. Okay, so I'm trying to be organized and I don't know how organized I am. Okay, so let's go here. It's only let me do 3 pages. How can that be? I have to add another page. Add page after. Okay, so here we want to start with, let's start with insulin. Okay, so insulin's a super duper important hormone, right? So it's gonna be released from the pancreas, okay, and it comes from these cells that are called beta cells. Okay, now what's gonna cause it to be released is an increased blood glucose. Okay, so the idea is it's gonna decrease your blood glucose. So let's just take it step by step. So I'm gonna do stimulus, and then we'll do receptor, and then we'll do control center, and then we'll do the effector, and then the results, the target organs, and results. So what's going to happen? Okay, so let's see if we can change colors. How brave are we? Okay, so insulin. So the stimulus is going to be an increased blood glucose. Okay, so that means you have a lot of sugar in your blood, or you have an increased sugar in your blood. Okay, so our body's goal is to get back into equilibrium and be equal, right? And maintain a constant blood glucose. Okay, so what happens is the receptor, okay, and the receptor is the pancreas, is monitoring the blood. Okay, so it's monitoring the blood, and it's looking for glucose, and it's trying to determine like how much is actually in there. Okay, so the control center is also going to be the pancreas. Okay, so the pancreas is what's going to make the decision about what's going to happen. Okay, remember the pancreas kind of looks like a little leaf, right? Looks like a little leaf. Okay, now the pancreas is going to release insulin. Okay, so the effector is always the hormone. Okay, so what's going to happen is that we are going to increase glucose uptake. So basically what's going to happen is your cells are going to start taking up glucose and storing it. Okay, we'll end up increasing our glycogen stores. Okay, so we put it away for a rainy day. Okay, it actually increases protein production. Okay, and it's going to increase lipogenesis. Okay, so basically what we're doing is this is the signal to turn on, not turn on, to start storing. Okay, now what's the result? Okay, so the result is always the opposite of the stimulus, okay, in these systems. So the result means that we're going to have a decreased blood glucose level, right? We're going to have a decrease in fatty acids, and we're going to have a decrease in amino acids. So they say that insulin reduces all of the fuel molecules. Okay, so we're going to have increased blood glucose is going to be the stimulus. Okay, then the pancreas is the receptor and the control center. The effector is going to be the hormone because it's going to cause the changes to occur in the cells. Okay, now the next one, let's see, we want to do glucagon. Okay, so glucagon is the antagonist of insulin. So what's an antagonist? Okay, so it's exactly the opposite. Okay, so it's going to do the opposite of what insulin does. And one of the tricks they say to remember is say it's released when the glucose is almost gone. Okay, so glucagon released when the glucose is almost gone. Okay, so guess what the stimulus is? So the stimulus is going to be that we have a decreased blood glucose level. Okay, so the receptor and the control center, oops, I'm not doing very good with changing my pen consistently, is the pancreas. Okay, so pancreas does both. Okay. So the pancreas, then the effector is going to be the hormone. Okay, so the glucagon. Okay, so it's going to get released from alpha cells in the pancreas. Okay, so it comes from the pancreas. Gets released from there, gets dumped into the blood, and then the result is going to be, and if you can't remember anything, you always can remember, okay, the basic result has got to be the opposite of the stimulus. So if the stimulus for this is decreased blood glucose, then the result is going to be an increased blood glucose. And how are we going to do that? What's going to happen? Okay, so what's going to happen is we're going to start cashing in some of our reserves. Okay, so we're going to take glucose from the glycogen that's in our liver. So we're going to do glycogenolysis. Okay, so that means we're going to take glycogen and we're going to break it down and we'll have glucose. Okay, so you have energy to make ATP. Another thing that's going to happen is lipolysis. Okay, so that means you're going to take triglycerides and you're going to break them down and you're going to get fatty acids and glycerol. So you'll start breaking down your fat too. Okay, so the glucose, we're cashing in what we stored before. Okay, so insulin and glucagon are going to work together to keep your glucose level consistent. Okay, so you're going to go up and down, and these two hormones are going to work together to do that. Okay, and they're going to make sure that your sugar stays the same. Okay, now this one, it doesn't do anything to your amino acids. So I'm going to put like a 0 and a line through it. It doesn't do anything to proteins, but it does stuff to your fats and your sugar. Okay, now the next hormone that we want to go over, and this one is a little more complex because it has an axis, is what they call it. Okay, so this is cortisol. Okay, so we started out with two that were really straightforward, but now we're getting into one that's I think it's a little trickier. Okay, so cortisol, the stimulus for it to be released it can be stress, right? So this is the stress hormone. Okay, so it could be stress. It could be negative feedback loop. So it could be that your cortisol levels are going down. So that it just gets released again to keep you in equilibrium. And then the other thing is it's part of your circadian rhythm. Okay, so after you get some sleep, like 3 to 5 hours or 6 to 8 hours of sleep, you start to release cortisol. So your cortisol is what it's doing is preparing your body to get up in the morning. Okay, so it's getting you ready for the stress of just getting out of bed. Okay, now here's where we get into the tricky part. Okay, so the receptor, what's detecting the feedback loop and the stress and the circadian rhythm, that is the hypothalamus. Okay, now your hypothalamus it's in your brain. I should have put a picture in here. Okay, so it's above the pituitary gland. Okay, so I don't know if I can draw a brain. Let me try. So here's the brain, right? And here's the pituitary. the hypothalamus is above it. Okay, so there's pituitary, and there's hypothalamus. Okay, so now the hypothalamus releases hormones that are called releasing or inhibiting. Okay, so it either has releasing or inhibiting in all of its hormone names. Okay, so what it's going to do is it actually controls what's going on in the pituitary. So if I take this pen, the hypothalamus, okay, is going to control what's going on in the pituitary. So lots of times they call the pituitary the master gland, right? But it has a master, really, because the hypothalamus regulates what's going on in it. Okay, so now if we go back here, okay, so the hypothalamus releases this thing, it's called cortisol releasing hormone. Or I'm going to abbreviate it CRH. Okay, so it's going to travel down the infundibulum, right, that little connection between the hypothalamus and the pituitary, and it's going to travel to the anterior pituitary. Okay, so pituitary has two parts, big part and a little part. Kind of looks kind of like that. All right, this is the anterior pituitary is the big part, and then the part to the back is the posterior pituitary. Okay, now the anterior pituitary, the hormones that it releases, we use this little TP flag thing to remember them. Okay, so TP flag, so we'll talk about some of those today. Okay, so CRH is going to come from the hypothalamus and it's going to go to the anterior pituitary. The anterior pituitary is going to release this thing called adrenocorticotropic hormone, which I'm going to abbreviate ACTH. Okay, now ACTH is then going to go down to the adrenal cortex. Okay, and the adrenal cortex is part of the adrenal glands. Those sit on top of the kidneys, right? So here's the kidney, right? And here's the adrenal gland, and the cortex is going to be the outside part of it. Okay, so we have it's this corticotropic axis kind of thing. Okay, so we're going to go from the hypothalamus to the pituitary to the adrenal gland. So it's a chain reaction. So the hypothalamus talks to the anterior pituitary, and then the anterior pituitary is going to talk to the adrenal cortex. Okay, and then what's going to happen is the adrenal cortex is going to release cortisol. Okay, and cortisol, what it's going to do, okay, is it's going to get you ready to start the day. Okay, so to get the day ready, what's going to happen in your blood, okay, so the effector overall, right, is going to be the cortisol in the long run. Okay, but the results are going to be, so what do you think you need to get out of bed? You need in your blood, you need an increase in glucose, an increase in fatty acids, and an increase in amino acids. Okay, so it gets you ready, it gets you going. Okay, so what's going to happen? Where are we going to get this? We're going to get this from the liver. Okay, so we're going to take glycogen and break it down to get glucose. We're going to take triglycerides and break it down from the fat. Okay, and then we're going to break down proteins too. Okay, so cortisol is a good thing in limited levels, okay, but if you have too much cortisol, you can have negative side effects, right? So too much cortisol is not necessarily a good thing, but we do know, right, it suppresses the immune system. So I always think about like at the end of the school year when everybody's tired and are totally stressed out, and then people start getting sick. Okay, so one thing, it can suppress the immune system, but we can also use steroids like cortisol-like things to suppress the immune system if someone's having too big of an immune reaction. Okay, so it inhibits inflammation. And another thing is it impairs connective tissue repair. So you don't heal as fast. So that's why if someone's on a steroid, they won't keep you on it for a very long time because it's got negative effects too. Right? It's not perfect. Okay, so let me try to go here. Let's see if I can do a highlighter. All right, what color do we want? Let's try orange, orange and purple. Okay, so here's the stimulus. All right, so stress, negative feedback, circadian rhythm. Okay, so now here's where the tricky part comes in. Okay, so the hypothalamus, okay, releases the CRH, okay, and that goes to the anterior pituitary. Anterior pituitary releases ACTH, okay, and that travels in the blood. So all of these are in the blood, right? They're going in the blood to the adrenal cortex. Okay, and then the adrenal cortex is going to dump cortisol into the blood. All right, so we could, if I get really sassy here, to make this red. So you remember these have to go into the blood. Okay. Everything's getting dumped into the blood because it's the endocrine system. Right. So then the goal, okay, to get us ready for the day is to increase our blood glucose so we have enough energy to get up. Then we also increase our fatty acids and increase the breakdown of proteins. So we have more amino acids in our blood. All right, now the next thing I have is thyroid hormone. Okay, and the reason it's kind of tricky is because it's the same kind of thing. So it's going to involve the hypothalamus and the pituitary. All right, so thyroid hormone, there's two of them. Okay, so we call them T3 and T4. Okay, and I'm not going to talk about those right now. I just want to talk about the homeostatic systems. Okay, so here's the stimulus. So the stimulus is going to be negative feedback. Okay, so it's a feedback loop. So when your thyroid hormone starts to go down, we need to get it back up. So we have a set point that we have to maintain. Other things that can stimulate you to release more thyroid hormone is pregnancy, being at a high altitude, cold weather, and hypoglycemia. So that just means you have low blood sugar. Okay, but our thyroid hormone needs to be at a set point to keep us alive. Okay, so receptor and the glands that are going to be involved. Okay, so hypothalamus. Okay, and the hypothalamus is going to release a hormone called thyrotropin releasing hormone. And I know I'm going to spell it wrong here. Thyrotropin. Look right? Yep. Releasing hormone. Which is, we're going to abbreviate TRH. Okay, so where's the hypothalamus going to, what's it going to talk to? So it's going to talk to the anterior pituitary. Okay, so it goes to the anterior pituitary. Okay, it is going to cause us to release thyroid stimulating hormone, which is TSH. okay, then this is going to go to the thyroid gland. Okay, and then we're going to release thyroid hormone. Okay, now what's going to happen? I know it could be, okay, thyroid hormone. What's going to happen is this is going to increase, so the result, okay, it's going to be it's going to increase your metabolism. Okay, glucose is going to stay flat, so it's not going to go up in your blood. Fatty acids will go up in your blood. Okay, and then amino acids go down. Okay, so the whole thing is it's also going to increase your body temperature. Okay, so we're freeing up glucose, but we're using it. Okay, we're freeing up fatty acids to supply energy, but this one's going down. So that means we're actually be making more proteins. Okay, so if we go back, let's look at this again. Okay. So if you look here, okay, so thyroid hormones, so T3 and T4, two of them, or them, okay? So the main thing that's going to control it, right, on a normal day is just negative feedback. Okay, so we're trying to maintain a set point. So it's going to be detected by the hypothalamus, but the hypothalamus is then going to release thyrotropin releasing hormone, okay, to the anterior pituitary. Okay, then that is going to release thyroid stimulating hormone, and that's going to go to your thyroid gland. And that's going to tell your thyroid gland, okay, it's time to release thyroid hormone. Okay, so then thyroid hormone, basically, it's going to increase your metabolism. Okay, so it's going to kind of speed everything up. It'll increase your heart rate, increase your body temperature. Glucose stays constant, but your fatty acids go up and your amino acids go down. Okay, now, if this is negative feedback, let's just go out here for a minute. Okay, so let me find a different color. Let's use green. Okay, you have to be thinking all the time about how all of this is regulated. Okay, so if something is, all of these are controlling each other, basically. Okay, so if, well, that's for another time. We'll do that later, but this is good for now. Okay, now the last hormone I have to talk about is growth hormone. Okay, so growth hormone is another one of those things that's gonna, it changes everything in your body, right? It's systemic. Okay, so the stimulus for it to be released, okay, is once again stress. Okay, circadian rhythm. Okay, so your sleep cycle. And then how many fuel molecules you have. So it's got to do with growth spurts too, right? So if your blood glucose goes down and your fatty acids go down in your blood, okay, but your amino acids are up, that's another thing that'll stimulate us to release growth hormone. Okay, so the receptor for growth hormone is going to be the hypothalamus again. Okay, so it is going to release growth hormone, releasing hormone. So notice everything that I'm saying from the hypothalamus, it either has releasing or inhibiting in its name. Okay, so growth hormone, releasing hormone. Okay, so it's going to go down to, guess where it goes? It's going to send a message to the anterior pituitary. And then the anterior pituitary is gonna send down. It's gonna send down growth hormone. So it's a little. This one's a little bit simpler. Okay, so your pituitary is going to regulate your growth. Okay, so then that's going to circulate in the blood, and then it's going to go to the receptor, the control center, the effectors, the growth hormone. Okay, so the result, right, is going to be that you're going to grow. And how are you going to grow? So what's going to happen, okay, is that glucose will stay the same. But fatty acids in the blood will go up. Okay, and then amino acids will drop. Okay, so basically we're going to get linear growth of the bone and the muscle and the cartilage. Okay, so that one, I tried to keep these simple, okay, so that it kind of hopefully makes sense. Okay, so another thing that's going to happen is the liver is going to release insulin-like growth factor. Okay, so it's kind of like insulin, so it's going to have the same results as insulin. Okay, the adipose tissue is going to start breaking down fatty acids. So think about kids when they start to grow, right? So they're putting on fat and they're getting a little bit rounder, right? And then they go through a growth spurt, and the growth spurt, glucose stays the same. They make more muscle, they make more bone, okay? And their fatty acids get used up, okay? It's actually released all the time, right? So it's released all the time in us, but usually it stays in homeostasis. And I think that's it.